Hello, myself, Dr. Animesh Chaturvedi. I am working with Indian Institute of Information Technology, Dharwad. The presentation is about minimum offense, inter-agreement hit terms, is stable rules, and the co-author is Dr. Rajesh Sharma, working with University of Tartu. The motivation and research question. The motivation is that there are too many hate term list available and hate speech data available, but still it is challenging to identify the hate term, how much that hate term is contributing towards a hate speech. Then the two analysis that we have done, quantitative analysis and qualitative analysis. We did inter-agreement hate term list analysis and severe hate term list generation. And in qualitative, we generated stable hate rules with the minimum stability threshold and transitivity and lattice analysis we have done. So the four research question one is about inter-agreement analysis, how better inter-agreement has been done. uh, then the severe hit term list generation we have done as research question two. Then research question three is how better classification that severe hit term list is can do. Then how to generate stable hate rules. Then the fourth 4B is about how to visualize these concepts and rules. Then, for the quantitative analysis, we'll study these things. For overview, in, inspired from the Shapley value, that the contribution of an individual hate term towards the hate speech. Then there are three classes which are being created: hate, relative hate, and no hate. So proposed matrix is basically three proposed matrix are there: hatefulness, relativeness, and offensiveness, to make the inter-agreement hate term list and generate the severe hate term list. Then single hate term list analysis, we have the first four artifact that we will discuss at in experimental section. Then fifth important artifact, that is about intra-agreement hate term list, is how to generate hatefulness matrix. If a hate term is occurring in a hate class, then its value is 1. Otherwise, it's 0. Then for creating relativeness, that for a hate data, the frequency of hate term in the hate class divided by the frequency of hate term in relative hate class and no hate class. Then combining the hate class and relative hate class, we can say this formula to be used: frequency of hate term in hate class as well as in relative hate class divided by frequency of hate term in the no hate class. Both of these matrices is used to generate inter-agreement uh, analysis for multiple hate term list. Then inter-agreement hate term analysis we have done using one hate speech data and multiple hate term list. So this inter-agreement analysis could be like a matrix that uh, IA, and this actually inter-agreement hate term list could be there, which could have offensiveness matrix, and which could have hate term list belonging, which hate term is belonging to which hate term list. So the list is being mapped to that hate term. So these two things are there in the result. So the what is the percentage of contribution of that hate term towards the hate class is being calculated with the help of offensiveness matrix. What is offensiveness matrix? It is a harmonic mean of hatefulness and relativeness. So the least value of offensiveness could be 0 for the non-hateful hate term, and the highest value it could have 1 for the very severe hate term. So usually the hit term would have offensiveness value in between 0 to 1. So this how to generate the severe hit term, answering the question 2, that for above a given threshold, that is minimum offense, uh, for a offensiveness matrix, means we have the offensiveness matrix calculated, and then if it is greater than zero point 0.5, it is greater than zero point 0.6, if it is greater than zero point 0.7. What are these 0.56, 0.6? These are of minimum offensiveness threshold, and above that we can separate out highly severe hit term with the less severe hit term. So the high value of offensiveness basically generate severe hit term list, and the severe hate term list helps in better hate speech classification as compared to the other set of hate terms list there. So this n hate term list are there, and there are three different classes that actually help to create inter agreement hate term list. And offensiveness value greater than mean offense for the hate terms, we will generate severe hate term list. Then, for the comparison purpose, inter-agreement confusion matrix has been created with true positive, true negative like this. So this it is basically help to calculate precision, recall, F measure. So there are various type of imbalancing in the normal speech and the hate speech. So we have used percentage of hate speech lines to evaluate to avoid the imbalance. So this true positive is basically like percentage of hate speech line with hate terms occurring in the hate class. Similarly, for the true negative, percentage of hate speech line without hate term occurring in the non-offensive class. Similarly, we can find out the hate, that TPTN, FPFN values. So eighth artifact is about summarizing the n hit terms that actually we'll discuss in the experimental section. So the rare instances, so usually the normal speech is too much, and there are few hate speech and less amount of hate speech. So this and there even the hate terms are very rarely occurring in the among the normal words. So the rarely co-occurring hate terms could be studied, and that could also create a value. So next we'll study the qualitative analysis of co-occurring hate terms. So it started motivated with the interestingness threshold. So for example, in association rule, if A occurs, then implies B will also occur with minimum support and minimum confidence as the two threshold. Then we proposed a minimum stability threshold, which was being published on IEEE transaction, and the another paper was appearing in the same venue. Then hate speech rule mining is basically like suppose a context anglo is the uh, is having allied with some slurs. So there are 19 tweets like that, and the out of them three tweets are being shown like over here. So this, if we count the frequency of the hate terms and the frequency of the contextual terms, and then we will able to generate these type of rule with support and confidence. So this, if we treat the database like ordered database, then this type of rules are association rules. With unordered database, with ordered database, we can able to generate sequential rule, because in ordered means sequential database. So it will only provide us one rule, and that is better as compared to the four rules, because the three rules are less interesting as compared to the one rule. So next, the stability. Stability is saying that the number of hate speech data in which that particular hate rule is occurring with given sufficient minimum support and minimum confidence, means stability of that hate rule should be high. If that happens, we should set a minimum stability as the threshold above which we will say that rule as stable hate rule. Then we have done this analysis only for hate term and named entity. What does it mean by stable hate rule? It says that if someone uses a hate term A, then most probably that person may also use hate term B with a given probability. Means if A is said, then most probably B will also be said. A is antecedent and B is consequent. So pre-processing we have done with the n hate speech data to generate the intermediate representational hate speech data, and after that we have done the stable hate rule mining uh, with this n hate rule set of rules are being generated with the support greater than minimum support and confidence greater than minimum confidence. Thereafter, we have generated stable hate rules such that stability of these rules should be greater than uh, minimum min step. Then we have done post processing to generate transitive graphs, lattice graphs, and concepts. There are the data set that we have used, the three data set, hate speech data set we have used, and these are their classes they defined, and these are our classes that we have defined. Then there are six hate term list, three plus three, so six hate term list we have used for analysis. First generation of severe hit term list experiment. So as we said, four artifacts. So these are the first four artifacts. That creation of hit term frequency, all hit term frequency, and top hit term frequency. These are the top hit terms. Means they are occurring frequently, and the percentage in what amount of percentage of line they are occurring. Then what is the outer join between the hate offensive and non-offensive classes? So the outer join in terms of classes, in terms of percentage. Then this intra-agreement analysis, we calculated this matrix one, that is hatefulness, matrix two, that is relativeness, for these hate terms. Then, in addition to the two matrix, we also calculated offensiveness for these hate terms and said it as inter-agreement hate terms. And this artifact would have six artifact inter-agreement hate terms. That hate terms and the three matrices that we discussed, along with the hate list which contains these hate terms. This answers the research question too. Then next, this inter-agreement confusion matrix has the seventh one for the comparison. So this bold one, offensiveness, with 0.717, so produce better result for the Davidson as compared to the Gorel. uh, so this for the similarly for the D Gilbert, the offensiveness greater than 0.46 means that severe hate term list has outperformed this union list, and the offensiveness greater than 0.75 for the GAO ETL database. This again outperformed the union list. This shows that our result had shown better and good results with severe hit term list. So severe hit term list did better hate speech classification. Why it is done? So it is done because uh, of the two facts. So the best recall needs less, almost zero FN, means false negative, and the best precision needs almost nil false positive. So this needs very large or very small hit term list, but we have to optimize the value between precision and recall. So we have generated optimized hit term list, and we keep most severe hit terms in the severe hit term list. So the comparison that we have shown for the Gorel and the offensiveness for the Davidson, and D Gilbert we have shown offensiveness and Union. So these are the rankings of the hit term list classification that could be able to do GAO, ETL. Then the summarization of the eight, that it is the eighth artifact, that all the hit database with their classes along with the list and all the list. So this type of multiplications are there. So this, what number of hit term are there and what are the number of entries are there, means number of lines that contains them. Then stable hit rules concept transitivities. So basically the bold one is the concept. and that concept is of the, for the left side is for the women's, and for the right side is for the region. So these rules are being generated and rules being converted to concepts, and the first set of graphs is basically transitivity, and second set of graph is lattice. This answers research question 4B. Then conclusion, we generated inter-agreement information. We answered 4 research question. We generated report for top frequent hit term, inter-agreement, summarize the hit terms, offensiveness value we have created for each hit term. Quantitative analysis we have done. We proposed the threshold of minimum offense. Then we generated severe hit term list. Then qualitative analysis, we propose stable hit rules, and we did the transitive and lattice graph generation. The acknowledgement. So we thank Professor Nishant, Dr. Bertie, and Dr. Jatinder for their initial discussion on this work. I would like to thank the Alan Turing Institute and King's College London to providing fellowship to do postdoctoral. Then this is the citation. What are the related publication to this stable rule mining? I already published in 2018 some part in SMC conference, and detailed version is published in IEEE transaction for the minimum stability, and the similar work is coming up in the system network analytics evolution and stable rules of state series on the same venue, that ninth uh, data science and advanced analytic conference. Thanks a lot, and hope you enjoyed the talk. Please email me any question. Thanks. Bye.